Hello, Go West attendees, and welcome to the Go Standard Library Bootcamp. In this presentation, we're going to look at some cool things you can do with the Go Standard Library to make your applications better. I'm Jeremy Morgan. I've been developing professionally for around 20 years and doing a lot of Go stuff lately. I recently built a cool Go course for Pluralsight. You can check out my blog at jeremymorgan.com or follow my crazy adventures on Twitter. In this talk, we're going to spend all of our time in code. We'll explore some ways the standard library can help you write better Go programs. We're going to look at formatting input in Go, formatting output in Go, creating your own logs, and working with strings in Go, including a way to speed up your Go programs. We'll be doing all of this with the Go standard library. Why should you explore the standard library? Easy. It's pre-written code. Tons of low-level functions that you don't have to worry about. It's developed and tested by the Go team. You can rely on this code to operate just as you expect. Finally, it's less work for you. You can pull pre-written, simple stuff from the library and focus on innovating cool features with your software. It's all available when you download Go. So let's get started. Okay, so I'm here at my Linux desktop, and you can run this on Linux, Mac, or Windows. Either way, the results are going to be the same if you're following along. Now I have Visual Studio Code opened up here, and what we're going to do is we're just going to look at the FMT package and look at scanning input and output from that package. Now this is a pretty common way that people use the FMT package to scan things in, using scanline here. We've got first name, last name as a string, and then scanline takes in first name and last name. And it asks, what is your name? Hello, Jeremy, nice to meet you. So this is the common scan thing that you see in tutorials and things like that when you're reading from basic input. But there's a much more powerful way to use the scanning utilities that are in the FMT package. Okay, so here I have a text file, and this text file is formatted. You can see name is blank years old. And there's a common format for each of these, but what we want is we just want the name and the integer. So we want the name and the age, and that's it. All the rest of the format we want to throw out. Now, what's a good use case for something like this? Let's say you've got a big text file with a million things in it, and it's formatted a certain way, like it's comma separated, or it's tab separated, or it's a log file, or something like that. And you want to extract little bits of information and put them into a database, for instance. Say, so we want to take this family.txt, and we want to take just the name and the age, and we want to insert those into a database with name and age. Here's how we'll do it with scanning. So now we want to open up family.txt. And this is also using the Go standard library. We're just using os.open to open it up. And let's create a new buff.io scanner, also a part of the Go standard library. So we have a buff.io scanner, and while it's scanning through the file line by line, we're going to read each of those lines and try to determine the format and extract the information from it. So we know that we want the age and the name. And what we're going to do is we're going to use the scanf that's in the FMT package. The first input is the text that we want to input. And this, of course, is going to be scanner.txt. Then we need to put in a format. Here's what we can use for the format. Now we see here we have name is blank years old, so we'll just copy that. And then we'll drop our tokens in here. And what we'll use here is called a format identifier, and that's just basically what kind of format Go should expect from this file. Now we know that name is text, and it's a string file, so we'll put %s, and we'll put %d because we want this to scan in as an integer for the age. So s is d years old. So now the next parameters are going to be where we put that data. Okay, so now we look at this, and scanf will take the scanner.txt, we'll look for this pattern, string is number years old, and it's going to take these two, and it's going to put them into name and age. So theoretically, we should be able to print out name and age. these should come from each line in that file using the format that we've specified here. Okay, and we'll drop our error correcting in here. Now we can say if we're going to get these two values, then we will print them out. I'm going to use fmt printf. Now this is doing the exact opposite of scanf. This is formatting the output as it goes out. So, just to recap, we're scanning in scanner.txt, which is a line of the file that we've shown here. We're scanning in scanner.txt, we're looking for this format, and we're extracting these two values, putting them into name and age. So, if we've got both of those two values, we'll print them out here. Let's run this. And there's our list of names and ages. Now, this is a great way to use scanf. And this works on any text string, readers, things like that. They all work with this scanf. Now, what is the use case, you might be asking? Why on earth would we want to do this? The biggest use case that I've used this for is when you're using text files, exactly like we're doing here. So we're going line by line through a text file. So if you're opening up a text file with data in it or logs or something like that, you want to be able to specify the format of the information and take it in. So you're doing just the opposite of printf. You're taking in data, formatting how you want it to look, and then storing that data, like in this case, in name and age, and then printing it out. So this is one of the awesome ways that the FMT package can use input scanning to format your input for use in other places. Like instead of printing this out here, we could just put it into a database. Okay, so I don't want to spend a ton of time showing you how to format output. I'm sure each of you have been through the tutorials, you've done things with printf, things like that. But I did want to show a cool little formatting thing that you can do with printf. Okay, so here we have numbers.txt. Now this is similar to the text we had before. Obviously we have 4 sets of floats here in each line, and we're going to display that in several different ways. Now what I have here is we're using scanf again, and we're just scanning in all these floats into value 1, 2, 3, and 4, and then we're printing out values 1, 2, 3, and 4. So let's see what that looks like. Okay, so it looks exactly as we'd expect. It's taking in all these values, storing them in a float 32, and then just printing them out exactly the same as they were put in. So this is essentially the same as running cat on numbers.txt. However, we can do some cool formatting things with this. Now, what if we wanted to round these numbers? And say that we wanted to round them for display purposes only. We don't want to round them to store them into a database. We don't want the actual values to be rounded and changed, but we want to round them out for display purposes. That's where printf comes in, and it's really easy to do that. Now notice here I put in 7.2f. So that means 7 digits here, dot 2 digits there. Let's see what this looks like. Okay, and so we've got this first value rounded off. Let's do it with all the values. So this is like a money format, right? So let's go ahead and break these into columns to make it more visually appealing. And see, that looks even better. However, all of these are right justified right now, as far as I can tell. What if we wanted them to be left justified? Check it out. It's that easy. Just adding that little dash makes it left justified. It's cool little tricks like this in printf that make things more visually appealing. And remember, you can also use printf to print your output and then pipe that into a text file. So I've done that before. Now, I've written things into a text file the standard way, where I'll take a string, format it, make it look cool, write it to a line, and put it into a buffer, put it into a text file. But there are times when you want to print output to make it look nice on the console, and maybe you'll pipe that into a text file as well. This is a good way to do it. And as you can see, we've rounded all these values. We've got them all left justified. We've got little columns here. Everything looks really cool. So I just kind of wanted to show that printf is very powerful. It is a powerful tool, and if you start looking through the documentation for printf, you'll see that there's just some amazing printing things that you can do with it. All right, so next we're going to take a look at logging. Now, you can get a bunch of different logging packages and full suites of software out there for Go. However, the Go standard library also includes some really cool logging functions. So if you're just building a small application that you want to do some logging on, and you don't want something big and complex and expensive, anything like that, the Go standard library has your back. So let's add some logging to this application that we just wrote. Now, one of the first things we'll do is we'll import log. And if you've done any tutorials or anything, log is pretty simple to use. What I'm going to do here is I'll show you a really cool way that I found to log things in a very simple manner. So we're going to create a set of variables here. And what this is a set of loggers. Now you can see the error levels here. We have warning logger, info logger, error logger, and fatal logger. Pretty easy to figure out how that works, right? And each of those has a logger attached to it. And we're going to create an init function here. Now in this init function, we're going to set up our logger. That way we can use it throughout the whole program. The first thing we'll want to do is open up a text file. Okay, and here we're opening up a log.txt, and this is just going to be a text file that we're going to write all of our logs to. Ironically enough, if we can't open this file, we will log a fatal error from the application. Now I'm going to create the info logger, and we'll do this one manually just so we can see kind of how it works. And I'm going to call this info logger, and we're going to use log.new. Now for the IO writer here, we're going to put in our log file. And next we'll have a prefix. Now the prefix is exactly what it sounds like. It's what you want to put before the log message. So for this one, we're going to call it information. Now everything that this logger writes out will say information and then the file. Now next you can see the flags that we need to put in. Now these flags are what actually goes into this log file. And since we're using Visual Studio Code, you can see some autocomplete here. And we obviously want to put the date and the time with each of the log files. So here we have log ldate. And then next I want to put in the time. I can put in UTC in here. We can put in ltime. For this, I think I'm going to put in ltime. And finally, we want to show which part of the file this came from. So we want to display a line number and maybe even a file name if possible. So here I'll do short file. And I'll show you the difference between short file and long file flags here. But right now we've got it set up here. So now we have an info logger. Let's go ahead and start using this info logger. And the way we'll do that is we'll use just infologger.println. And here we're going to say, starting the application. And maybe we'll say that we're initializing a new scanner. And we'll put in here that we found a line. And we could just sprinkle these info messages all over the application. Okay, so now we have our info logger with all of our messages here. So let's run it. Very cool. So our application still ran just as it usually does, but now we have this new file here. And there's our prefix that we put in, information equals. Here's the date, the time, and the file name that was used with the line number. And you can see starting the application, init buff.io scanner, we processed the line 3 times at line 45, and then we finished the application. Cool, right? Now this is pretty verbose. You probably wouldn't do this in a regular application, you'd end up with some pretty huge log files. But for demonstration purposes, this works pretty well. Now, what happens if we have a problem? Like here, if we can't open numbers.txt, then we've got a problem. So what I'll do is I'll rename that numbers.txt and we'll run this again. As you can see, we have an error down here. However, we have nothing in the logs showing that. So let's change that. Okay, let's put in a warning for this. You could argue that this is a fatal error. If you can't open this file, the program can't run. But for demonstration purposes, let's just put in a warning. And now we have our warning here. And let's just do a warning logger before we panic. And we're just going to say if we can't open numbers.txt, then we'll print out could not open numbers file. Let's run it again. And we get our error again. But now we have a warning. At line 34, we could not open the numbers file. So that enables you to go in and say, okay, we have an error at line 34. Where does that error come from? Oh, it comes from opening numbers.txt. And it panics after that. So we'll add a few more error levels here. So now we have info, warning, error, and fatal. Now let's go ahead and change this to a fatal logger error. That's a little bit more accurate. We run our file. Okay, it dumped on us. And there we go. We have our fatal error. Now you might notice something different here. This log is a little bit longer. And notice it shows the full path name to our file. That's because I used a long file here instead of short file. If I change it to short file, then it will look like the other ones. It'll just say scan.go. So there's a lot of different options with these flags. You can look them up on the Go website, and you can just mix and match these tags to your heart's content. You can build a log file to the exact format that you want. So this is how we can set up basic logging functionality in your application. So to recap this, we created a set of 4 loggers here. Then in our init function, we opened up the log.txt file. Then we instantiated a set of loggers here. And then in our application, we can call each logger, call the printLine method, and print out something to our log file. And it all makes for a nicely formatted log file, all with the Go standard library. Okay, next we're going to take a look at strings. Now what we're going to do is we're going to look at casing first, like uppercase, lowercase, and title case. So let's dig in. Okay, now here I have a sample string. The trouble with programmers is you can never tell what a programmer is doing until it's too late. Often very true. Okay, and the first thing we'll do is we'll print this out. Cool. So it's printed out exactly as it sits here in the sample string. Now, one thing that we can do with our strings library is we can change the casing of this. This is often important for things like comparison and display purposes. So if we want to make a lowercase version of this, it would simply be strings.toLower with our sample string. It takes our sample string as input, and it returns a lowercase version of that string. Simple. Now it's completely lowercase. Now, as you probably guessed, strings.toUpper makes everything uppercase. And there we go. Now the string is in complete uppercase. Cool. Now, why would you use this? Now, as I've said, one of the things to use it for is comparison. So let's look at strings comparison and see how that works. Okay, so now I have 2 strings here. Now these strings actually say the same thing. However, the case is different. So if we want to do a basic comparison on this, we already know what it's going to come out to, right? So if we run this, it says the strings are not the same. However, in some cases when you're doing a string comparison, you want to see if the string is the same, but not necessarily the case. This is a case-insensitive compare. And now we're going to change both strings to lowercase and then compare them. And it says the strings are the same, which we already know. So that's great. But is this the best way to do string comparison with the Go standard library? No, it's not. So now I'll show you a cool function that's in the Go standard library that is a lot faster and more efficient than this comparison. And it's called equalfold. And we'll just copy everything from here. And we'll delete that. And now with strings.equalfold, we can do that exact same comparison. It's a case-insensitive comparison of the two strings. And it says the strings are the same. Now if we do actually change the content of the string, they're not the same. And we know that. Now you might be asking why I'm showing you this. And the reason I'm showing you this is because there is an optimization advantage to be had here. What I'm going to do is create a set of 3 functions that do 3 different ways to do string comparison. So the first function I have here is compare operators. Now this just uses equality operators to do the comparison. What makes it a case-insensitive compare is that we're doing strings to lower to each of the values before comparing them. Our next one is compare string. This uses the strings.compare function out of the strings package. We are also doing a strings.toLower on each of those values to make this a case-insensitive compare. Compare EF is the final function, and it just uses equalfold as a function to do the comparison. Equalfold automatically lowercases the 2 values, so it's a case-insensitive comparison. Now we'll compare all 3. Okay, now I have some printf statements that are going to show the output of each of these functions. Let's run it. Okay, compare operators, compare string, compare equalfold, all show true. Let's change the actual text of the string. And they all show now that it's false. Now, which one is the fastest? Now, string optimizations may not sound really sexy and cool. However, they do add up to big performance, especially with highly scaled applications. So let's find out which of these functions is the fastest for processing a string comparison. Okay, so now I have my compare.go file that I've built here. And what this does is compares these 2 strings. We've got the list of functions, but now we have a test file. And within this test file, I've set up a set of benchmarks. Now, as you can see, we have function benchmark compare operators. Passes in the testing object, and what this does is it runs this loop n amount of times until it comes up with a good stable result for benchmarking. And what it's going to do is use the compare operators function to compare the 2 strings. Now what this does is it compares each of these functions and it benchmarks them and times them, and we'll see which one is the fastest. So we're going to run go test -bench equals dot, which means run all of the benchmarks within our test suite for this application. And I'll open this up a little bit. And as you can see, equalfold is a lot faster than the other 2. Let's run it a couple more times. And as we can see, equalfold wins every time. So the takeaway from this lesson is, if you're doing case-insensitive string compares, use the strings.equalfold function to do that. It's very, very fast. And this is included in the strings package in the Go standard library. Thank you for hanging out with me for the Go standard library bootcamp. If you have any questions, feel free to email me. Check out my blog at jeremymorgan.com or follow my crazy adventures on Twitter. Also, check out my course on Pluralsight titled The Go Standard Library. We go in depth with the standard library and all the cool stuff that you can do with it. So thank you and enjoy the rest of the conference.